Welcome to the first episode of our series, Design Patterns in Java. Over the next 10 episodes, we'll break down the most common and practical design patterns that every Java developer should know. In the first episode, we're starting with one of the most widely used and often misused patterns, the singleton. You might have used it in a logging class, a config manager, or to manage database connection. But despite being so common, many developers still get the implementation wrong, especially in multi-threaded environments. What actually is the singleton pattern? And I'm small. What actually is it? The singleton pattern is a creational pattern that ensures a class has only one instance, and it provides a global point of access to that instance. This pattern is useful when exactly one object is needed to coordinate actions across the system. Think of it like this. If your application has a centralized logger, you don't want to accidentally create 10 different loggers. You want all the logs to go through the same single instance. So some real-world use cases would be a global logging service, configuration managers, thread pools, shared cache or registry, or a database connection manager. All right, let's go through the first example, and that is about eager initialization. Here we have a simple logger. We have a instance, which is a private static variable, and it initializes the single logger. We have made the constructor private, so no one on the outside can create a new instance because we have created one instance here. And we have a getter method, which is getInstance, which returns the instance to you. And then we have a public method called log, where you can actually log stuff through the instance. So now in main, we can just call simple logger, get the instance, and log something. And when we run it, it just runs hello world. So amazing, right? It works. We have created a singleton pattern and we can stop the video right here because you've learned everything you needed to know. Well, no, there are some stuff that we still need to go through. The instance here is created when the class is loaded by the JVM. So it's immediately always created. Sometimes you don't want that. Sometimes it's a big thing that you need to set up. Right here, it's just a simple thing. But sometimes it's an object that takes quite a while to load. And you don't want to immediately load it on startup time because that makes your application boot way slower. It's inherently thread safe due to Java's class loading mechanism, but it lacks lazy initialization. The instance is created even if it's never used, like I said before, right? Now, what if you only want to create the instance when you actually need it? That's called lazy initialization. And here's the naive implementation that looks fine, but is not thread safe at all. So here we go through the unsafe logger, right? We have the unsafe logger, we have an instance, which is not immediately created. You see the difference, right? There's no immediately created object, so it makes your boot time faster. We have the getInstance method, and what it does is it checks if there is an instance. If it's not there, it creates a new instance for you. Otherwise, it just immediately returns said instance that is already created or the newly created one. Very simple. If two threads call getInstance at the same time, and instance is null, both threads may create different instances, breaking the singleton guarantee. So now, what do you actually want to do to fix this? Because this just broke your application. Well, we can create a synchronized lazy logger. A synchronized lazy logger uses the synchronized keyword. Wow, wouldn't you have thought of that? What the synchronized keyword does is make it thread safe so that when two threads call it, it's only created once. Very simple explanation of what it does, but I think that just shows the power of the keyword. The con with using synchronized on your method level is that it adds overhead to every call, even after the instance is created, right? Because you now have all this synchronized overhead. So now what we can do is we can create a double-checked logger. A double-checked logger is also using the synchronized keyword, but what it does is it doesn't use it on the method, so it isn't used every single time you call getInstance. It's only used once when the instance is null and we need to create a new instance. That's what it does right here. It uses the synchronized keyword to go into this class, check if the instance is null, and then set a new double check logger, and then returns that instance, ensuring thread safety and ensuring the singleton pattern. Beautiful code right here, right? That's what you'd think. Now, we can also use the Bill Pugh singleton. I think it's Bill Pugh, Bill Pugh. I don't know. If I butcher the name, please don't hold me accountable. Let's go through the code. So the Bill Pugh logger, what it does is it has a logger holder class. So it has a private static class, logger holder, and it has an instance, which is a new Bill Pugh logger. If you call get instance, it calls the logger holder and accesses its instance variable, and then it returns that. So the logger holder class isn't loaded until get instance is called. The class loader also guarantees thread safe initialization of the static field and no synchronization overhead at all. This is considered the best practice for lazy loaded singletons in Java. Some best practices and tips on using the singleton pattern. If performance is critical and you don't need lazy loading, use eager initialization. If you need lazy loading, prefer the Bill Pugh implementation. Avoid using synchronized unless your JVM version is ancient, pre-Java 5. Avoid using singleton for global mutable state. It can lead to hidden dependencies and tight coupling. Use dependency injection frameworks like Spring to manage singletons cleanly. Thanks for watching episode 1 of Design Patterns in Java. We saw how the singleton pattern helps ensure a single global instance and how to implement it safely in modern Java. In the next episode, we'll explore the factory method pattern and how it helps us abstract away object creation while staying in control of which subclass gets instantiated. And don't forget to like, subscribe, and share this with your fellow developers. Have a great day and happy programming.